and were asking me, how do you do these find the 6 trig ratios? And you know how you do them if I tell you the sine, the cosine, the secant or the cosecant, but what I haven't told you yet is how do you find the other, the other 5 trig ratios when I tell you a tangent? So the question that does it, I believe, is question 26. So I'm going to do a version of 26. So suppose I tell you that the tangent of t, in my case, it's -4/3, but in your case, it'll probably be something different. And they also tell you that the sine of t equals 0. Now, what we normally do here, and we're going to do it in this one as well, don't we find the terminal point? Right, the x and the y coordinate. Because once I know the x and the y coordinate, then we can just get all the answers from here, right? And also, don't we need to know what quadrant it's in? Because that will tell me whether it's a positive or negative number that we're working with, right? So let's get the quadrant sorted out. I'll do a little picture. All sine, tan, and cosine. Now, the tangent is negative in this quadrant here, right? And this one here. Right, so put the numbers in. There's the first quadrant, there's the second, here's the third, and there's the last one, there's the fourth. And if we also now use the fact that the sine, I put equals, the sine is greater than 0, that's better. And the sine is positive in the first quadrant, and it's also positive in the second quadrant. So we agree now that the angle is in the second quadrant. Agreed? Right, that's the only place where the tangent is negative and at the same time the sine is positive. So I know that t is in the second quadrant, and when you're in the second quadrant, your x is a negative number and your y coordinate is a positive number. So that you knew how to do. Nothing, nothing to see here. It's the same. Now, that guy is a problem. When it's sine, it's dead easy. If it's sine, I know what the guy is, right? Yeah. If you tell me the sine, I know the y coordinate. If you tell me the cosine, I know it's the x coordinate. If you tell me what the cosecant or the secant is, if I turn them upside down, I get the y coordinate. If I turn it upside down, I get the x coordinate. All those are great, but not the tangent. So this is a new piece of information. Okay. This is a trig relationship. We call them identities. And this is the one that you just have to write down and memorize. And what it says is that for any angle t, tangent squared t plus 1 equals secant squared t. Now, I don't know if any of you ever knew that or saw it somewhere, and oh God, I remember that way back in high school or whatever, right? But that guy is crucial to answering this question. Because what I'm now going to do is I'm going to use the fact that I know what the tangent is, and this will allow me to get what secant squared is. So the tangent is -4/3. So -4/3 squared plus 1 is going to be the secant squared. That guy is 16/9 plus 1 is the secant squared. And if you combine them together, you get 25/9 is the secant squared. So far, so good? Now, what would I do to both sides to find out what the secant is equal to? What should I do to both sides to find out what the secant is equal to? Right, now, if you take the square root of this one, it comes out really nice. Would you agree it's 5/3? Now, technically speaking, isn't it plus or minus the square root? So it's plus or minus 5/3. So I'm going to have to figure out, is the secant positive 5/3 or is the secant negative 5/3? And where's my little guy got to? Oh, it's over here, right. Don't we know that the angle is in the second quadrant, right? We found that out. Isn't the secant behaves just like its partner, the cosine, right? These two go together. So in the second quadrant, the cosine is negative. And so in the second quadrant, won't the secant be negative? That makes sense. So this guy is negative 5/3. That's how I figured out that it was a negative answer. Now, we're slowly getting there. I know it seems like it's a, why are we doing this? But we're slowly getting there. Isn't the secant the same thing as 1 over the x coordinate? So negative 5/3 is 1 over the x coordinate. So what does that make the x coordinate? If 1 over x is this fraction, what will x be? And it's quite easy to do.
Negative 3/5.
It's reciprocal. Hey, took a while, but don't we now know the x coordinate? Negative 3/5. Do you see how we done that? We started with this, that allowed me to eventually find out the secant is. I know the secant is just a reciprocal to get the cosine, so that's essentially the x coordinate. How do you think we're going to get the y coordinate? I know the x coordinate.
Unit circle.
Do it in the unit circle. Yeah, you nailed it. So I'm now going to use that guy. I know x is negative 3/5 squared plus y squared equals 1. I know that's 9/25. As long as I do it to both sides, it's okay rule. So I'll subtract 9/25 and I get 16/25. And then I'll take the square root, and the square root of that comes out really nicely. But I still have that plus minus problem. Well, we've already cured it. Isn't our answer in the second quadrant? So that makes the x a negative number, right? And the y a positive number. So the one that we're going to use here is positive 4/5. So we now have the coordinates of the terminal point. It is negative 3/5, comma, positive 4/5. And that's the x that we're going to use, and that's the y value we're going to use. Excuse me, I should always turn my phone off, shouldn't we? It includes me. There we go. And so many bits of paper, I've lost the one I want. There we are. Can't we use these 6 formulas to get the secant, the tangent, the cotangent, whatever it is we need, right? Do you want me to do that bit, or can we just, yeah, I know how to do that bit, right? Because once you get to this, can't you get all of these guys? For instance, you want the cosecant, 1 over y, 1 over 4/5, 5/4. There's the answer to that one. Do you want to know what the cotangent is? The cotangent is the x over the y. It's negative 3/5 over 4/5. The 5's cancel, and there's your answer. Are we good with that? Any problems? So that is how you find the missing trig ratios when you're told what a tangent is equal to. So it's a little bit more involved, wasn't it, than the other ones? The other ones were a little bit quicker, and that's fine. Tony, what's your question?
So how did you get the equation tan t squared plus 1 equals secant t squared?
Oh, that is an identity. What that means is you trust me, it's true because I'm a mathematician, right? They're actually going to be a section that we deal with trig identities. And in trig identities, we prove things like this. But right now, you're just going to have to trust me. There's another one that I think a lot of you have seen, although we don't need it for these questions. Have you ever seen one of the trig rules, they're called identities, that looks like that? Have you ever seen sine squared t plus cos squared t equals 1? You ever seen that one?
Yes.
Isn't it the same as the unit circle?
I believe.
You can get it from the unit circle. That is another one of those, trust me, I'm a mathematician, right? You know. So you're just going to memorize that one. I'll write it down somewhere so it's handy. And you're only going to use it, aren't you, when you get a question where they tell you the tan of t is 4/5 or the secant of t is 10/11, right? That kind of thing, right? Okay. Let's do one more example, but this time, let's suppose I tell you that the secant of t is 1/2, and I tell you that the cosine of t is less than 0, so it's negative. And from that information, we're going to find all the other trig ratios, right? So this time, not secant, space, cotangent, right? Right, we haven't shown you how to do a cotangent one, right? I've shown you a tangent, let's do your cotangent, okay? So first thing I'm going to do is figure out which quadrant the angle T is going to be in. So all, sine, tan, cos, okay? Who does the cotangent pair with? Well, the cotangent and the tangent are partners. So in other words, if this is positive, so will that be. If this is negative, so will that be, right? They partner, right? So when is the cotangent positive? Well, it's going to be positive in the same places where the tangent is positive. And the tangent is positive in the first quadrant and in the third quadrant. So far, so good. Now, where is the cosine negative? Well, the cosine is going to be negative in the third quadrant, and the cosine is going to be negative in the second quadrant. So you put those things together, and now we know that T is in the third quadrant. Are you comfortable about the logic that we use to do that? Right? A cotangent and a tangent are essentially the same. So I found out where the tangent was positive, 1 and 3. I found out where the cosine was negative, which was 2 and 3. There's only one where both happen, so that's why it's the third quadrant. Let's check. Now, in the third quadrant, the x is negative and the y is negative. Agreed? So any x coordinates I get, any y coordinates I end up getting, they're going to be negative values when we do that. So now, cotangent is 1/2. What is the tangent?
2.
Right, turn it upside down, you get 2. Now we use that piece of how did you come up with it? And my answer is still, can you just trust me it's true and use it? Right. Now, what does that give me? It gives me 2 squared plus 1 is secant squared. 4 plus 1 is 5. Gets me secant squared. Then to find the secant, I take the square root of both sides. Agreed? And the answer is positive or negative. Agreed? Which is it going to be? Is the secant going to be positive or negative?
Negative.
Agreed. Are you all comfortable? If you're in the third quadrant, that's just the same as a cosine, and the cosine's negative. Right. Now, if the secant is that guy, doesn't that make the cosine 1 over that guy? You're comfortable about that? The secant, cosecant, right? Secant, cosine. Right. You're the upside down version. Now, there's another way of looking at that that also works. If I start back with this guy, the secant is 1 over x. So won't that make x, that guy. And in this case here, cosine is x, so that makes x that guy. You see that both ways of looking at it still give me the x coordinate. So I now know that the x is -1/5.
Would you want us to clean that up?
I would, and I'm glad you picked that up. But I'll leave it right now since I've kind of committed to it, but I will tidy it up when I'm finished. So I'm now going to use the equation of a unit circle to get the y coordinate. So this guy is -1/√5 squared plus y squared equals 1. If you multiply that by itself, you end up with a fifth. If you subtract 1/5 from both sides, you get that. And y ends up being plus or minus the square root of 4/5. But don't we also know the y coordinate is negative? Almost screwed up there, right? It's 2/√5. So I now know this guy, and it's also negative, and it's 2/√5. So I know I have the coordinates of my terminal point. It's -1/√5 and -2/√5. Now to make them look pretty, rationalize the denominator, and you get that guy, and rationalize the denominator, you get that guy. And now we know the x, and now we know the y. We can find anybody we like. If you want to know the cotangent, yeah, that divided by that. You want to know the sine, it's just that guy. You want to know the cosine, just that guy. You want to know the cosecant, take the y coordinate and turn it upside down. Do you want to see another one of them, or are you comfortable about how it works? Got a thumbs up? I like thumbs up. We're good. Well, we're almost finished, which is good news because we have to be finished by the end of today, because that's the second section that you need your homework for, and that's where your test is going to be. The last piece of the puzzle is more time consuming, I would say, than difficult. It's just, is what it is. So let me show you what we're talking about here. The ones that we've still to do, I'm calling them applications. These are using trig functions in equations and so on. So question 28, can I make that bigger? Let me see if I can make that bigger. There we go. Because some of your screens might not be, probably overdid it. Right. You see the equation hopefully a little bit clearer now, a little bit bigger. Right, so everybody's blood pressure varies over the course of the day. We all learn something. That kind of makes sense. Do you know when you're sleeping, isn't your blood pressure probably going to be a bit lower because you're rested, right? And then you're waking up, it picks up. That's what they're getting at. In a certain individual, the resting diastolic blood pressure at any given time t is given by this equation here. So their blood pressure at time t is given by 85 plus 4 times the sine of this ugly fraction. And the time is measured since midnight. So basically, isn't 2 a.m. just another way of saying t is 2, right? And noon would be another way of saying t is 12, right? And 4 p.m. would be t is 16, right? Does that make sense? So we are just simply going to do calculations. So I'm going to go back to my screen so you can see the buttons I'm pressing on your calculator, and I'm deliberately going to do a mistake. Okay, so here goes. So the first question was, what would the blood pressure for this person be at 2 a.m.? So it's 85 plus 4 times the sine, what's it, pi t divided by 10, so that's pi, there's its own little button, times 2 o'clock, and divided by 10. Now, let me tell you, my deliberate mistake is not in anything I've typed, right? I've not put a 2 where a 4 should be, right? That's not the mistake. And I'm going to hit enter, and you're going to get an answer that seems reasonable, yet it's still wrong. And I type that, and I round it off to 1 decimal place, because that's what the homework tells me to do. And I type in 85.0, right? That's 1 decimal place. And I check it, and it's wrong. And I scratch my head, and I look at it, and I think, I haven't done anything wrong. What have I done wrong? Because I have.
The pi times 2 divided by 10?
No, nothing wrong with that.
Is that
Although,
not?
no,
The order of operations?
no, you could do 2 times pi divided by 10, it would still work. That's not the problem. But see, it's dead easy to miss this. I'll show you the problem. Because none of you kind of answered it. Can you see what's wrong with my calculator setup?
You're
You're in
degrees,
degrees
not
instead of radian.
How many of you have done that in your trig life in previous incarnations? Isn't it very easy to have that on degrees when you know it should be radians, right? Now, if I redo that entire calculation, there we go, and I put enter, you see I get a totally different answer, right? 87.4 roughly. And that is the correct value. So what I'm getting at here is you might do everything perfectly correct, except you're in the wrong mode. You're going to type your answer in, and whatever sign's going to tell you're wrong, and you're maybe going to do the same calculation again and get the same number and just pull your hair out in frustration. One of the simplest mistakes that I have made, and everyone else probably as well, is to make sure that you're in radians when it should be in radians. And of course, make sure you're in degrees when it should be degrees. So you might say, well, how do I know one from the other? Right, here is the original question that they were giving us. And they don't mention radians or degrees, right? They just write it down like that. But here's the big, big clue. If you see pi, doesn't that really mean it is almost guaranteed to be radians? Would you agree? If there's a pi somewhere, it's radians, right? The second one is more subtle, but if they wanted you to do it this way, they really should put a little degree symbol on it, although very rarely do they ever do that. You see the little circle that means degrees. I wish textbooks were better to you by putting in a degree symbol. Normally, all you will get is that. And somewhere in the written stuff up here, they'll mention at least once the word degrees. So sometimes you don't know it's degrees until you read the story. Sometimes they don't even mention degrees, in which case the only real clue is a pi or a tiny little circle mark. I guess the last resort is, since you get 5 shots, if it doesn't work with one, couldn't you just switch it over to the other and see if it's degrees when you thought it was radians? Hopefully they'll never do that to you. So are you comfortable that I could find the blood pressure at 2 a.m., 5 a.m., at noon, at 4 p.m., and so on? Right. That seem reasonable? I'm not going to do the exact answer, but if you imagine that being when you woke up, 2, 4, 6, 8, 10, 12, there's noon, 2, 4, 6, 8, 10, 12, and there's midnight. If you did a little snapshot at 1 o'clock, 1 a.m., 2 a.m., 3 a.m., and so on, you would see something like this. Try to figure out what this would look like. Yeah, it would look like this. You see your blood pressure rises, then it goes down, and it rises. It would look something like that. Okay. Any questions about 28? No. Well, move on then. Going to do question 29. And this application tells you about bungee jumping. You know what that is? You get a little picture and you bounce and you go back up. And what this one is the height is 120 plus 90 e to the negative t over 18 cosine a pi over 7t. So it's just a big ugly formula. So like every question, all you're really going to do is hit buttons on your calculator, right? And be careful, and that's it. Now they want all these answers to be rounded off. So here is t equals, and so t represents time. So you can imagine, this is the ground, that at time t is 0, then 1 second mark is 2 second mark, 3 second mark, 4 second, it goes back up a little bit, 5, 6, 7, 8, 9, 10. You know, you can imagine that doing thing, right? And h of t is going to tell you what it is, the height above the river. And I'll do a little snapshot. We'll do it at 0, and we'll do it at 6, and I'll do it at 12, right? It's really all to do with your calculator. Do you think it's radians or degrees, even though they don't mention it?
Radians.
Right. Let's have a rule. If they don't mention it, it's always radians, right? So if they want it to be degrees, they should really tell you, shouldn't they? Right. So that, I think that rule will probably save us. Now, I can do this 2 ways. First way is laborious, but it's safe. The second way is dangerous, but it's quick, right? So here is laborious, but normally quite accurate. 120, gotcha, plus 90 times e, there's the e button, e to the power, a negative, make sure you hit that when you need a negative. T over 18 is just basically 0 divided by 18, close the little power bracket, times cosine pi t over 7. I know pi, I'm going to times it by t, which is 0, a bit pointless, but I'm doing it, divided by 7, close the brackets and hit enter. And the answer I get is 210. Now, if I wanted to do it when t equals 1, wouldn't I just do that entire calculation, but replace all those zeros by 1, and then do it with 2, and then do it with 7, and then do it with 12? Can you imagine how laborious and boring that's going to be? Right? So I promised you there's a quick but dangerous way to do it. Right? So let's show you how that works. Hit y equals on your calculator and type in that equation. The only thing is that the t's are going to be called x's. No big deal. 120 plus 90 times e to the power negative x divided by 18, close that one, finish with, times cosine pi 7 thingy, so pi x divided by 7, close brackets. Okay, so type that in. Now, if you do that bit right, you're halfway to getting it correct. So all I've done right now is type in essentially this formula. So far, so good. Now, underneath the Windows button, in very tiny letters, it says TBL set. That's table setup. So I'm going to hit my blue button and table setup. And all you need to do here is make sure that this row here that says independent, that the ask is highlighted, right? Make that highlighted. Gotcha. That's all you need to do. Don't need to worry about these numbers, don't need to worry about that, but make sure that says ask. And then lastly, you go second, right at the end, table, second graph. And if there's numbers from previous questions, hit delete, make them go away. Right, I want that entire table. Type in 0, the answer better be 210. What about 1 second mark? There you go. 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds. How many do you do? And 12 seconds. Do you see how quick that was? And then all you do is round off the answers to 1 decimal place. So at the 1 second mark, the height will be what, 196.7, right? And then this one would be 170.2, and this one here would round up to 104.0 and so on. Are we good with that? Now, why is it dangerous? If you do not type this in, won't every single one of your answers be wrong? Right? If you type it in wrongly. So as long as you are comfortable that you'll do that correctly, and pretty much apart from that, isn't it just hit the number, enter, hit the number, enter, and the rest is done automatically? Would you agree that's a good time saver than having to do every single one, you know, from scratch every single time? Any questions about that?
I do have a question. I can't find the y equals button on the calculator.
Right. If you look at my calculator here, if you get a TI-84,
I have a TI-85.
it should be the same. Do you have a string of buttons along here? And there's one at the left-hand side called y equals. Do you have that?
No, so.
Okay. Do you have? I'm kind of hard to show on these screens. Can you, if you take your thing and stick it right next to your camera, I might be able to see what you've got. Can you do that?
It just has some numbers.
I'm not sure your calculator has got that feature. To be honest, I'm not 100% sure.
Yeah.
I know that you can get an app for your phone that emulates a TI-84. I hope it's not that expensive. Or you could get a loaner from the mesh department. Just go talk to Cheryl. It's a good idea if you email her. So her name is C. Phillips, Cheryl Phillips, CPH, I'll write it down.
Yeah, actually, I did have a TI-84 calculator downloaded on my phone, and it's right there. So
okay, so well, then you don't need to worry about the other one, right? So that's what you do. You are good to go. If you just think too many buttons and I don't have a TI-84 anyway, I guess you're just going to do it one at a time, aren't you? You'll get the answer.
I have a question.
Yes.
So if you are doing it the second way, are you able to do like, let's say 13.5 or like a decimal point? Or do the answer as well?
Yeah. You could find out where he is at 1.23456 seconds if you wanted to. It doesn't care. It's really, really quite cool. Now, let me return back to the screen, the homework screen, and show you what that question looked like. Okay, so here's the bungee jumper. You see that equation I was talking about, that one there? And you would put in here 210, and then the next answer I have is 196.7. And so on. You comfortable with that? So what's the last application? Oh, there's a little picture of them dangling. What is the next one? Really, same story, different formula. So you essentially do almost exactly the same thing, but this time a slightly different equation. Any problems so far? Pirate joke. What is a pirate's favorite letter of the alphabet?
R.
You
Like
would
it's
think
R?
it. You would think it was R, but it's not. His first love has always been the sea. No.
That's a good one.
Oh, okay. I don't know what you're like. You're kind of, you keep it to yourselves. Okay, we need some jokes here. So has anybody got a joke? Not one of you have a joke. I think I've run out of pirate jokes. Okay then, why is a seagull called a seagull? Don't know? Because it flies over the sea. If it flew over the bay, it'd be called a beagle. Oh God, you're a
That
tough
one's also
crowd.
pretty good.
Okay.
No, our mics are just muted.
Okay, is it Mike's muted? Right. One more joke, and then I'll tell you we'll be finishing off today. So we've got we actually finished at a really good space. I don't want to start something new. So my last joke for today, what shall we do? Did I do the one about the aircraft with the American and the Frenchman? Okay, so that means I've picked on the French, haven't I?
Mm-hmm.
So let's pick on the Canadians then. So Canadian was walking down the street with a crate of beer on his shoulder, happy as anything, walking down the main street of his town. And he notices across the road his friend, and he waves, and his friend waves back. And then his friend looks at him and says, "What's that you've got?" And he goes, "Oh, it's a crate of beer for the wife." And his friend said, "That was a good swap."
That's pretty good.
Okay, French jokes.
Yeah, that one was good.
Okay, last one. You've suffered enough. Last French joke. Pick on the French. What is the difference between a Frenchman and a canoe? No, let me rephrase that. What's the difference between a Canadian and a canoe?
I can do
Don't know? Canoes can tip. No, that's all I got for you. Okay, so put down your names, your last name for attendance, and I'll get this thing that I want to show you set up, and that will be us once I've done that. So you're doing the names while I get myself organized. Here we go. I think we're ready. I'll need to go in and out. Looks like everybody's done that. Good. Maybe make this a little bit bigger. Let's do it as a student view, that might help. Okay, this one here. Almost there. I should do that as a student view. Okay, right. So right now you lot should be looking at WebAssign and essentially our homeworks. Don't bother about that one. In fact, I might make that one disappear just so you can't see it. All you need to do for this coming week for your homework is 5.1 and 5.2. We just finished 5.2 today, actually a little bit earlier than I thought we were. And here is online test 1. Online test 1 will be questions from these two. You've got 2 hours to do it, which is more than enough time. Most of you won't even use nearly 2 hours, but it's better have more than enough. And you see that funny little, looks like a stopwatch? I don't know why it's saying 1 hour 30, but I guess that's me. I must have clicked on it somewhere when I was checking it out. This is your test. It's on the first 2 sections. You get, it's slightly different from homework. The first thing is, it won't tell you if you're right and it won't tell you if you're wrong, but you will have 5 guesses. So if you make a mistake and you want to change your answer after you've checked your work, just type in the second answer you want and hit submit and it'll take it, right? But when you enter that homework, that clock has evidently happened because it's now 1 hour 30 for me. You've only got 90 minutes to finish it, right? Or I'll say it again, you've got 2 hours to finish it. But the minute you click it, the clock keeps ticking. So don't leave it. You know, go and have a coffee, come back and think, well, it's just like homework, because an hour will have gone by and you won't be able to catch it. You must get it done by midnight Sunday. If you don't have it done or you didn't even start it, that's going to be a 0. You're allowed to drop 2 without it affecting your grade, but try not to drop this one. I think this is probably one of the easier ones to do well in. Homework is due on midnight Friday, midnight Sunday, as the others are. Don't do your test until you've finished your homework and you're really ready, right? You're prepared. There's nothing that can happen that you can't do. It's all open book, including your test. So if you've got notes or you did a question similar to it and you've got some work in, go back and have a look at it, refresh your memory, that's fine. All I will see is the answers because it's WebAssign. It doesn't give me much more than that, and that's fine. But if you don't get your homework finished, you will email me and say, can I have an extension? And I will give you extra time. But if you ask me for an extension, then that means you don't get the extra bonus participation point for doing homework on time. Tests do not get extended, right? But homework can. Any questions?
You said we have 5 chances, like even on the test.
Yeah, but you won't know that the first one's right and you change it to the second one that's wrong. So it's not like, I'll guess, nah, okay, I'll guess again, nah. Oh, I guess it's right, I'll keep that one, right? You won't know which of your guesses is the right one.
Okay.
So you do get 5 shots, but that's just because people will do it and then they'll check it and think, darn it, he told me about that Radiant thing and I still didn't do it. And now I've realized that I did it in Radiant, you know, and okay, that one has to get changed and this one has to get changed. Well, you can do it, right? Because you'll get 5 shots. That's kind of what it's there for. Any other questions?
When you say open book, does that also mean that we can like go over this lecture as well?
Yeah.
Use it? Okay.
Yeah, that's okay. Make sure it's written down. The midterm and the final will be much stricter. So you can watch my video for the online, that's fine, right? But in the midterm, all the videos will disappear. You won't be able to see them. And all the homework that you've done previously won't be there. So in this one, you could go and look at your homework and say, oh, I'm going to write that one down because that's a good one. I'll remember how to do it, right? But in the midterm, everything disappears. So you can only do whatever you've physically written down.